children, in this video we will see some examples. First example is prove that delta of del is equals to delta minus del. Okay. Let us see solution of this problem. Delta of del is equals to, okay, we have in previous video we have seen that the relation between delta and E is delta is equals to E minus 1 and del is equals to 1 minus E inverse. Therefore, here delta can be written as E minus 1 into 1 minus E inverse. Okay. Multiply these two brackets, we get E into 1. Sorry, here is a multiplication. Delta into del. So, E minus 1 into 1 minus E inverse. E into 1 is E minus E into E inverse minus 1 plus E inverse. Okay, which is equals to E minus E into 1 upon E, obviously 1. Minus 1 plus E inverse, okay, which is equals to, take E minus 1 in one bracket plus E inverse minus 1 in another bracket. We get, this is the definition of delta, E minus 1 can be written as delta plus E inverse minus 1 is nothing but del. Here you can give a reason, since E minus 1 is equivalent to delta and E inverse minus 1 is equivalent to del. Okay. Here is E minus 1 minus 1, here is 1 minus E inverse, okay, and this is a delta minus del, since delta is equals to E minus 1 and 1 minus E inverse is equals to del. Okay. Now let us take second example. Second number example is evaluate the following. Evaluate the following. Which first one is delta cube of x square. Second one is delta of x plus cos x. And third one is delta of tan inverse of x. Here you can write tan inverse x. Okay. Let us see solution. First we have to evaluate delta cube of x square. Okay. We will see solution of first. Here, f of x is equals to, see here, delta cube of x square. Means this delta cube is operate on this function. Therefore, f of x is equals to x square. Therefore, f of x plus h, replace here x by x plus h, we get x plus h square. Okay. Now we have a relation, delta of f of x is equals to f of x plus h minus f of x. We have already discussed the definition of delta, which is equal to, therefore delta square of f of x, this delta square can be written as delta of delta f of x, okay, which is equal to delta, but delta of f of x is f of x plus h minus f of x, okay, which is equal to operate delta on both f of x plus h and f of x. We get delta of f of x plus h minus delta of f of x, okay. Here see, we have to first calculate delta x square, which is equal to delta f of x is f of x plus h minus f of x, and here we replace f of x by x square, therefore delta x square is equal to f of x plus h, means here is x plus h square minus x square, okay, which is equal to x plus h square, x square plus 2h plus plus h square minus x square, okay, which is equal to x square gets cancelled. Here is 2xh plus h square, which is equal to h, here h is common, so take it outside, and in bracket remains 2x plus h, okay. Now we have to calculate delta square f of x. Delta square f of x is delta of f of x, okay, which is equal to delta of f of x is f of x plus h minus f of x, which is nothing but delta f of x plus h minus delta f of x, okay. Here delta f of x plus h is x plus h square, delta of f of x plus h is f of x plus h, f of x plus 2h minus f of x plus h minus f of x is f of x plus h plus f of x, okay, which is equals to f of x plus 2h minus 2f of x plus h plus f of x, okay, which is nothing but f of x plus 2h is x plus 2h square minus 2 into f of x plus h is x plus h square plus x square, okay, which is equal to, expand this bracket, we get x square plus 4 into xh plus 4h square minus 2 in bracket x square plus 2xh plus h square plus x square, which is equal to x square plus 4xh plus 4h square minus 2x square minus 4xh minus h square plus x square, okay, which is equals to, see here, x square plus x square is 2x square, and 2x square minus 2x square gets cancelled, okay, 4xh minus 4xh, 4h square, here is 2h square, it's 2h square, Del square of f of x is 2h square. Now we have to calculate delta cube of f of x, means delta cube of x square, which is equal to, this can be written as delta of delta square of f of x, which is equal to delta of f of x plus 2h minus 2 f of x plus h plus f of x, okay, which is equal to delta of f of x plus 2h minus 2 into delta of f of x plus h plus delta of f of x, okay. Delta of f of x plus 2h is nothing but f of x plus 3h minus 3 in minus f of x plus 2h minus 2 into f of x plus h, here is 2h minus f of x plus h plus f of x plus h minus f of x, okay, which is equal to f of x plus 3h minus f of x plus 2h minus 2 into f of x plus 2h minus 2 into f of x plus h plus f of x plus h minus f of x, which is equal to f of x plus 3h, see here, f of x plus minus f of x plus 2h and minus 2f of x plus 2h is, here remains only minus 1 minus 2 minus 3 into f of x plus 2h minus 2 into f of x plus h, here is plus f of x plus h, here is plus, so plus 3 into f of x plus h minus f of x, okay, f of x plus 3h square minus 3 into x plus 2h square, because here our function is f of x is equal to x square plus 3 into x plus h square minus x square, okay, x square, now expand this bracket, x square plus 6xh plus 9h square minus 3 into x square plus 2xh plus 4h square, okay, plus 3 into x square plus 2xh, here is 4, okay, 2xh plus h square minus x square, okay, which is equal to x square plus 6h plus 9h square minus, multiply in this bracket by 3, we get 3 into x square plus, here is minus, so here is minus 12xh minus 12h square plus 3 into x square plus 6xh plus 3h square minus x square. Okay. See here, this x square. Okay. X square minus 3x square, and means x square and x square get cancelled, minus 3x square plus 3x square is cancelled. Here is 6xh plus 6xh is minus 12xh. So minus 12xh, 6xh get cancelled. Here 3h square, 3 plus 9, 12h square, and minus 12h square get cancelled. So here remains 0. Therefore, del cube of x square is equal to 0. Here we can say that del cube of x square is equal to 0. Okay. Second, we have to evaluate delta of x plus cos x. Delta of x plus cos x. Okay. Delta of x plus cos x. We know that delta operator is distributive over addition. So distributive is delta of x plus delta of cos x. Okay. Delta of x, which is nothing but x plus h minus x, plus cos of x plus h minus cos x. Okay. By using definition of delta. Here x plus h minus x. Here only remains h. Plus, here use the formula cos a minus cos b is equals to 2 times sin a plus b upon 2 into sin b minus a upon 2. So, here a is x plus h and b is x. Therefore, it becomes 2 into sin of x plus h plus x is 2x plus h upon 2 into sin of b is x minus x minus x minus h. Therefore, it here remains minus h by 2. Okay, which is equals to h. Now see here, you know that sin of minus theta is always minus sin theta. So take this minus outside, therefore this plus become minus 2 sin 2x plus h upon 2 into sin h by 2. Therefore, delta of x plus cos x is h minus 2 into sin 2x plus h upon 2 sin h by 2. Okay. In third, we have to prove that, we have to find tan inverse of x, which is equals to delta of tan inverse of x is tan inverse of x plus h minus tan inverse of x, okay, which is equals to tan inverse. Here again we can use this formula, tan inverse of a minus tan inverse of b is nothing but tan inverse of a minus b upon 1 plus a into b. Okay. So here is this x plus h is a, and here is suppose this x is b. Okay. Therefore, this becomes tan inverse of a is x plus h minus b is h upon 1 plus a is x plus h into x, okay, which is equals to tan inverse of x get cancelled, h upon 1 plus x square plus xh. This is the delta of tan inverse of x, okay. Let us take third example. Third example is evaluate delta raised to n e raised to ax plus b, where the interval of differentiating taken to be unity, okay. In this example we have to evaluate delta raised to n of e raised to ax plus b, okay. So here our function is here f of x is e raised to ax plus b, and the interval of differentiating is taken to be unity, means here h is 1, okay. Delta of f of x, what is the definition of delta of f of x? It is nothing but f of x plus h minus f of x. But in this example we have given that h is equals to 1, which is equals to f of x plus 1 minus f of x, since h is equals to 1, okay. Now first we will find delta of e raised to ax plus, okay, delta of e raised to ax plus b. Delta of f of x is f of x plus 1. So here replace f by e raised to ax plus 1, we get e raised to a. Here is x plus 1 plus b minus e raised to ax plus b, okay, which is equal to, see here, after simplifying this we get e raised to ax plus a plus b minus e raised to ax plus b, okay. This term can be written as e raised to a into e raised to ax plus b minus e raised to ax plus b. In these two terms e raised to ax b is common, so take it outside, and in bracket remains, here remains only e raised to a and here remains minus 1, okay. Therefore what we get? We get delta of e raised to ax plus b is equal to e raised to a minus 1 into e raised to ax plus b. Now we will find delta square e raised to ax plus b, okay. Delta square of e raised to ax plus b can be written as delta of delta e raised to ax plus b, okay. And we have already calculated delta of e raised to ax plus b, and this is delta of e raised to ax plus b into e raised to a minus 1, okay, which is equal to, but here this e raised to a minus 1 is constant, so take it outside, e raised to a minus 1 into del of, because this term does not contain this term does not contain x, therefore it is constant. E raised to a minus 1 into delta of e raised to ax plus b. Again, use value of delta of e raised to x plus b. It is nothing but e raised to a minus 1 e raised to x plus b, which is equals to e raised to a minus 1 square e raised to a plus b. Sorry, here is ax plus b. Here is also ax plus b. Okay. So observe that delta of e raised to x is e raised to a minus 1. Here power is 1. E raised to x plus b. Delta square of e raised to x plus b is equals to e raised to a minus 1 square. Here power is 2. So, proceeding in the same way we get, or therefore, okay, proceeding in the same way we get, what we get, delta raised to n into, of e raised to x plus b is equals to e raised to a minus 1 raised to n e raised to x plus b. Okay. Okay, we will stop here. Thank you.